Hello viewers, welcome back to the course on scientific computing using MATLAB. So in the previous lecture we have started with the Lagrange interpolating polynomial, and then we have discussed the drawback of that polynomial, that if we have to add one extra point, then we have to repeat the whole process to compute that Lagrange interpolating polynomial. So to get rid of this one, we start with the another polynomial, and that is called the Newton divided difference formula. So today we will discuss that how we can define Newton's divided difference formula or interpolation. So in this case, again I have the points. So I have some points, that is x0, y0, x1, y1, x2, y2, x3, y3 and so on. So in the end I will suppose I get xn, yn. So these points are given to me. Now I define the what is meaning by the divided difference table. So first of all I will define divided difference. So in this case, suppose so these points are given to me, and let I rearrange these points and I write the points in the form of x0 less than x1 xn. So this is the ascending order I am taking. Now I define the first divided difference. So first divided difference I represent by square bracket x0 x1. So this is equal to f at x1 minus f at x0 divided by x1 minus x0. Similarly I can define f at x1 x2. So this is equal to f x2 minus f x1 divided by x2 minus x1. So same way we can define all the first order. So xn minus 1 xn. So this one can be written as f xn minus f of xn minus 1 divided by xn minus xn minus 1. And if you remember from the previous one, that this can be written as forward at fx0. The only condition was that in that case we know that, so this h was uniform in that case, so that is why x1 minus x0 was equal to h. So we are not dividing by h there. So it is similar to that one, only thing is that this we have defined for uniform spaced nodal points, and this is for any, it may be a uniform and non-uniform. So this is only for uniform data, that is equispaced. So this is the first divided difference we have discussed. Similarly I can define the second divided difference. So in the second divided difference, suppose I have 3 points. So points are given to me. So suppose I will write f at x0, x1 and x2. So this can be written as f at x1 x2 minus f, the first order divided difference x0 x1, and divided by the last x2 minus x0. Similarly I can define my x1 x2 x3. So this is equal to f of x2 x3, the first order difference formula, x1 x2 divided by x3 minus x1. So in this way I can define all the second order divided difference formula. So in the end I will get f of x n minus 2, x n minus 1 and x n. So that can be written as f x n minus 1 x n minus f x n minus 2 x n minus 1 x n minus x n minus 2. So this is the way we can define the second order second divided difference formula. So similarly we can define the nth order divided difference formula. So in that case it will be, I am writing that f of x0, x1, x2 up to xn. So that can be written as f at the n minus 1th order divided difference formula. So that will be x1, x2 up to xn minus f x0, x1, x2 up to x minus 1. So divided by xn minus x0. So based on this one I can define all these divided difference formulas. So now we can write the, so based on this one we can make the table for this one. So divided difference table So divided difference table we can write same as the finite difference table. So I have the value of x and this is the value of y that is given to me. So x0, x1, x2, x3, x4, suppose these values, 5 values are given to me and this is y0, y1, y2, y3 and y4. So the first divided difference dd. So that can be written as here. So this is y1 minus, so I can write instead of formula I can write the expression. So this will be, so this is y0 is the value at fx0, this is f at x1, this is fx2, because we know that this data points are given to us and that is based on some function. So from here I will get this is equal to x0, x1, the first finite difference, divided difference, x, x2, x2, x3, x3, x4. So this is the first one. The second divided difference is, so from here I can write this as f, so this and this, so it will be x0, x1, x2, this will be x1, x2, x3 and this will be x2, x3, x4. So I can write the third one. So this is f x0, x1, x2, x3 and this is x1, x2, x3, x4. And the last one is the fourth one. So that will be the only one value, the constant value. So the fourth divided difference will be x0, x1, x2, x3 and x4 using all this value together. So this is the way we can write the divided difference table. Also, if I write f of x0, x1, so this is equal to f of x1 minus f of x0, x1 minus x0. This I can write as fx0, fx1, x0 minus x1. and this can be written as, I can write this as f of x1 x0. So, in this case I can say that the ordering of this coefficients or the values of x0 and x1, the indexing, so that does not matter. It does not matter we write x0 first and then x1 or x1 first x0, the value of the divided difference will be same. So, that is there in this case. Also, so this way written. Also we can write from here that f of x0 and x1, so this is equal to, I have written like this one. So, this can be written as f at x0 divided by x0 minus x1 plus f at x1 divided by x1 minus x0, because from here I take the negative sign. So, negative sign I will take here. So, it will be x1 minus x0 plus fx1. So, now from here I can write, we can write f at x0, x1, x2 directly from here. So, this can be written as, first I will write f of x0 divided by, so x0 minus x1. So, I will write x0 minus x1 and then x0 minus x2 plus f x1. So, this will be x1 minus x0 and x1 minus x2, and in the last one it will be f x2 divided by x2 minus x0 and x2 minus x1. So, the third finite difference can be directly written in this form, and from here we can say that the interchanging of these arguments or the value of xi does not matter, it will be same. So, from here I can write the directly the nth order divided difference. So, this will be the summation all f xi, right, divided by the product of all x minus xi. So, I am taking moving from 0 to n, right. So, I am taking x0, x1, x2 all. Here I am also going from here. So, in this case I can say that this is, I should take I and this is I should take j. So, I am taking j from 0 to n and j is not equal to I. Like if I take I is equal to 0, then it will be x0 minus x1, x0 minus x2 and all these values except this one. So, one value will become, so that. So, this is the expression for the nth divided difference formula. Now, based on this divided difference, now we want to find out what is the interpolating polynomial in this case. So, I want to define now Newton's divided difference interpolating polynomial. So, this one we want to write. So, let the function f x be a function whose values are tabulated for the given x is equal to x I is moving from 0, 1 up to n, which are not necessarily equidistant. So, which are neither necessary, should I write here, neither necessarily equidistant nor in any order. So, this is not necessary in any particular order. So, no ordering is given to me and they are not also equidistant. So, in that case what we do? So, we put them in the order. Now, let us suppose without loss of generality, that the ordering is this one, x0 is less than x1, x2 less than xn. So, we put that in the ordering, the ascending ordering. Then suppose we have only 2 points. Suppose so case 1, we have only 2 data points, that is x0 and x1. So, this is x0 and x1. So, I have only 2 data points. So, in that case I will write my interpolating polynomial, that is p1x. So, in the p1x what we do? We write, so this value is given to me. So, I will write f at x0, whatever the value is given to me, because this value is like this one. We have the given nodal points. So, data points are like this one, x i's and corresponding y i's. I is moving from 0, 1, 2 up to n, and y I is equal to f at x I. So, that is already given to us. So, I will put f x naught plus, then I put x minus x naught and the first divided difference, that is x0 x1. Now, let us check this. So, now from here I know that if I passing through 2 points, it should be linear. So, it is a linear interpolating polynomial, and if I put x is equal to x0, so this x minus x0 will cancel out, I will get f x0, that should be there, and if I put p1 x1, so this will be x1, and from here I can write as x1 minus f of x0 divided by x0. Now, if I put p, so let us verify this one. Now, p1 at x0, so this will be all 0, so that should be equal to f0, and p at x1, so this is f x0 plus x1 minus x0, f of x1 minus f of x0 divided by x1 minus x0. So, this will cancel out, this will cancel out, and that will be f of x1. So, based on this one, px naught fx naught, px1 fx1, so it is the interpolating passing through these 2 points. So, this is a linear interpolating polynomial p1x. Now, what I do that? Now, suppose we add one more point. So, now suppose I have x naught, x1, and I have added another point, that is x2. So, 3 points are there. So, it should be quadratic. Then I can write my p2x taking the help of p1x. So, from here I can write this is as f at x naught plus x minus x naught, that is already there, first finite difference, first divided difference x0 x1. So, this is, I know that this was my p1x. Now, I add one more term. So, that is x minus x naught and x minus x1, and then the second order divided difference. So, this was my p1x, and I have added one more terms, that is x minus x naught into x minus x1 f. This is the second order divided difference formula, and then it will be my quadratic polynomial. So, from here I can verify that my p2x will be fx0 plus x minus x0 f at x1 x0 divided by x1 minus x0 plus x minus x0 x minus x1, and then I can write from here. So, this will be f, the first final divided difference. So, this will be x2 minus f x1 divided by x2 minus x1 minus f of x1 minus f of x0 divided by x1 minus x0, and then this will be x2 minus x0. Now, from here I can write, now we have, if I put x equal to x0, so this will be all 0, this all will be 0, I will get fx naught. So, p2 at x0 will be fx0. Now, p2 at x1, so this will be f at x0. So, x1 this is here, so this all terms will be 0. So, this will be x1 minus x naught x1 minus x naught. So, this will cancel out, this will cancel out. So, this will be equal to x1. Similarly, I can write p2 x2. Now, let us see what will happen. X naught plus x2 minus x0 f x1 minus f at x0 divided by x1 minus x0 plus, now x2 I have to substitute here. So, this will be x2 minus x0, x2 minus x1, and divided by, here I am taking this x2 minus x0, and then it will be f of x2 minus f of x1, x2 minus x1 minus of f x1 minus f x0 divided by x1 minus x0. From here I can take the LCM x2 minus x1 and x1 minus x0. So, if you see from here, this one can be written as x2 minus x1, x1 minus x0. So, it will be f x2 minus f x1 minus the same factor into x2 minus x1. So, this expression will be there, and now all the terms will be cancelled out. So, that we can verify from here, then this p2 x2, then it should come is equal to fx2. Only this term will be left, all other term will be cancelled out from here also, and then we can do the verification with this one. So, from here I will get my p2 should be equal to p2 x2, that should come as a fx2. So, this we can verify ourselves, just a little bit we have to do some calculation. So, based on this one, now suppose, so now I want to do the generalization. So, now suppose we have n plus 1 points. that is x0, x1, x2 up to xn. So, now from here I can write directly my nth degree Newton interpolating polynomial. So, that will be equal to f x naught plus x minus x naught, the divided difference, the first divided difference, plus x minus x naught, x minus x1, second divided difference, so on, and in the end I will get x minus x naught, x minus x1 into n minus 1, and this is the nth divided difference. So, that is the nth degree interpolating polynomial using the divided difference formula. So, from here also we can say that my p n x can be written as p n minus 1 x, like we have seen here that in the p2x I was using this value. So, that was up to this it was p1x, and I have added this term, right. So, from here I can write pnx is equal to pn minus 1x plus the last term. x0, x1, x2 up to xn. So, now from here I can say that in the Newton's divided difference formula, whatever the interpolating polynomial exists at the given number of nodal points, if we add one more nodal points, then there is no need to rewrite the whole expression again, just add one more terms in the previous written interpolating polynomial. So, this is the way we can define the nth degree interpolating polynomial using Newton divided difference formula. Now, so in this case the error is given as we have discussed in the previous lecture also. So, Rx is given as x minus x naught, x minus x1 up to x minus xn. So, that is already there, but in this case it is multiplied by the divided difference. So, that is x0, x1, xn. So, the one value is given to us, that is x and x0. Now, maybe I can write again. So, this is the divided difference. X, I choose any x, and x naught, x1 up to xn. So, that is my error, where x belongs to the interval x0 to xn. So, in this case I choose any x in between, and then I write the divided difference, multiply with this factor. So, that will be the error. It is error we can find when we apply the Newton divided difference formula. So, in this case I can write as compared to Lagrange interpolating polynomial Newton divided difference Newton divided difference interpolating polynomial is easy to write and can be extended to added more tabular point. So, as compared to the Lagrange interpolating polynomial, Newton divided difference interpolating polynomial is easy to work, easy to write, because we can see that we can write very easily, and it can be extended to the added more tabular points, because in this case we are using the interpolating polynomial which is given to us for the less number of tabular point, as we have already discussed. So, this is all about that how we can define the Newton divided difference formula. So, let me stop today. So, today we have discussed with the drawback of the Lagrange interpolating polynomial, and then we started with the divided difference formula given by the Newton, and then we have discussed that how we can write the Newton's divided difference interpolating polynomial. So, in the next class we will continue with this one. So, thanks for watching this, thanks very much.